We can also prove statements by showing that the contrary would invoke a contradiction. I will use this method to prove the irrationality of square root 2 and the infinite number of primes. To prove that root 2 is irrational, we assume the contrary, that it is rational and so can be written as the ratio of two integers with no common factors, a over b. Squaring both sides gives us this expression, meaning that a squared is 2b squared. This 2 means that a squared must be even, i.e. it can be written as 2 times something else, call it n. We state here that since a squared is even, then a itself must be even. Writing a as 2n, since it's even, we can rearrange to write b squared as 2 times n squared. In the same way, this tells us that b squared, and hence b, are even. Here we have the contradiction, since we have shown that both a and b are even and hence multiples of 2, which contradicts our statement that a and b had no common factors. Proving the infinity of primes by contradiction requires a bit more imagination and work. We assume the contrary, that there are not infinite primes, and so we can say that there are n prime numbers, with n not infinite. We can list out all of these primes, starting at p1 is 2, p2 is 3, and so on all the way up until pn, the final prime. For this proof, we will use the product of all of these primes, p1 times p2 times p3, and so on up until pn. Now we define the number capital N is 1 plus the product of all of these prime numbers. N must be bigger than the largest prime, Pn, and so it cannot be a prime number because there are no prime numbers larger than Pn. This means it must have prime factors, which means there must exist in this list of primes a Pi, which will be between 2 and the biggest prime number, that is a factor of capital N. This Pi is also a factor of the product of all of the prime numbers. And if something is a factor of two different things, then it must also be a factor of the difference between these things. The difference between them is just 1. And here we have the contradiction. Pi is meant to be a factor of 1, but it also has to be a number greater than or equal to 2. And these cannot both be true. So there must be an infinite number of prime numbers.